Thank you everyone for joining us tonight for the Teaching with Tinkercad webinar. This is the 5th one of the school year, and we're excited to have you here tonight. We've got a great variety of panelists who are joining us along with our Tinkercad crew here. To get started, we want to invite you to answer our warm-up question in the chat. What career or careers interested you when you were growing up? And then also feel free to introduce yourselves to each other in the chat. And we'll give people just a few minutes to continue rolling in, and we'll get started. And again, thanks for joining us tonight. Kellyanne, do you know what you wanted to be when you were young?
Yes, Jenny, I actually thought about this question. When I was growing up, I actually wanted to be an artist, and particularly an animator. I was very into animation, and it was weird because my parents actually did support the idea of me going to art school, to the point that I was like, no, parents, I want to go to a liberal arts college and get a wider array of, of learning. So it was kind of a weird story. What did you want to be when you grew up, Jenny?
So I wanted to be a writer pretty much right away. And my influences were Peggy Parrish of the Amelia Bedelia series.
Very nice.
And Judy Blume, I think, came later. But yeah, that was my
course.
Yeah.
Classics.
Yeah.
And we're getting a lot of participation in the chat. I'm noticing a lot of our participants wanted to be teachers, which makes a lot of sense. And I did sort of want to be a teacher, but maybe an art teacher when I was growing up.
Right.
SeaWorld. Someone says they wanted to be a storyteller, a professional dancer.
Nice.
To be a teacher, an engineer, so that our aspiring engineers will be excited to hear from our guests tonight. An inventor, an architect. Ooh, Uchenna, we have an architect, psychologist, a ballerina flight attendant. Love it.
Wow. Wow.
Guidance counselor, a toy buyer, an Egyptologist, then a musician, and then a math and music teacher. That looks kind of like my resume. A teacher forever. A chemist. There's someone here who wanted to build a product called Tinkercad. I'm wondering who that is. It might be someone from the Tinkercad team.
Possibly Guillermo.
Maybe it's Guillermo.
Yeah.
Police officer, teacher, librarian, and our friend is from Toronto, Ontario. Please let us know where you're coming from too. We get a global audience here.
Yeah.
Marine biologist. This is fun, Jenny. I think I want your job during this webinar.
Social conversations.
Social worker, mechatronics engineering. We have friends from Alaska and Illinois with us tonight.
Nice. Well, fantastic. Thank you everyone for joining us. For those of you just getting started, go ahead and log into the chat. Let us know where you're from. And we were asking participants what they wanted, what they imagined their career would be when they were young. And so the topic this evening is exploring career connections during Career and Technical Education Month. And my name is Jenny Fennell. I'm the Content Development Manager here at Autodesk on the Youth Education team. And I am based on the West Coast of the US in Oregon. And I am joined here by my wonderful colleague, Kellyanne Mahoney. And Kellyanne, do you want to say a few words to introduce?
Thank you, Jenny. My name is Kellyanne, and I am a youth program specialist at Autodesk. Prior to joining Autodesk, I was a teacher. I'm a national board certified teacher, and I was taught primarily middle school English in the Boston Public Schools for 13 years.
Great. And there's a number of ways you can connect with us on social media. We have our handles for Instagram and Twitter here on the screen. And then if you happen to be posting on social media, a good hashtag to use is Tinker Together. And so we've got a great variety of panelists here this evening, and they will do more in-depth introductions in just a moment. But at a high level, I want to introduce Jason Erdreich. And Jason is a technology engineering and design educator in the public school district of Madison, New Jersey. So welcome, Jason. Thank you for joining us tonight. And we also have Uchenna Okere. And Uchenna is the founder and CEO of RevitGods. And we're really excited to hear your stories and experience, Uchenna. So thanks for being here. And we also have Aram Goganian, and Aram is the founder and co-owner of Predator Cycling LLC. So thank you for joining us, Aram. We're really excited to share our panelists and their stories with you this evening, and we encourage you to keep the conversation up in the chat. And if you have any specific questions for our panelists, go ahead and put those in the Q&A, because we will have a formal session at the end where you can get those questions answered. And of course, the Tinkercad crew here welcomes you. Thanks for joining us. It's really exciting to have you here and having engaging participation and discussion. So I want to tell you a little bit about how to participate. So as you know, there is the chat feature in Zoom here. And then, as I said, if you wanted to ask specific questions to our panelists or the Tinkercad crew here, go ahead and use the Q&A box there. And we will have a couple polls and quizzes, I think 2 of them this session. So you'll see those pop up when we get to those sections. And we will be sending out a recording of the webinar as well as the slides, which do have embedded links in them. So if there's information that's going by too quickly, don't worry. You'll get access to all the information when we send it to you early next week. So some of the goals tonight for our session is we want you to imagine how Tinkercad can be used as a resource for students exploring careers. We wanted you to feel that you can discover insights and experiences from what our panelists are sharing with you tonight. We'd like you to think about learning experiences that might align with your career and technical education goals in your school or your district. And we want to encourage you to ask questions to the panelists and the Tinkercad team. And so here's just a broad outline of what we're going to go over tonight. Kellyanne is going to walk us through an overview of Tinkercad. I'm going to talk some about using Tinkercad to explore careers. Jason is going to speak with us about developing CAD skills in middle school. Uchenna is going to talk about CAD skills in the design and construction industry. And then Aram is going to talk about CAD skills in product design, followed by our Q&A. So that's how our evening is going to be structured. And let's take a pulse of the room to get started. How often do you use Tinkercad? And you should see a poll pop up here in just a moment.
Jenny, did it pop up?
There, what's that?
Did it pop up?
It did, yes. Yeah. So is everyone, I wonder if everyone can see this. How often do you use Tinkercad? It's not activating. Relaunch poll. Okay, I'll try it again. Are you seeing that, Kellyanne?
I see it.
Okay.
Yep, and everyone is seeing it now, Jenny.
Okay, good.
It's very exciting to watch all the data come in.
Yeah.
And it's looking like, wow, we have a lot of Tinkercad Power users who use it almost every week. And we also have a lot of newcomers, so welcome. We're so excited that you're here to join us. You picked a really special episode to join too.
Okay, so.
All right, so I'm gonna end the poll now.
Okay, sounds good.
And so thank you for joining us for the poll, and we are excited.
Yeah, so Kellyanne, you wanna go ahead and take it away? Talk about
Sure.
Tinkercad overview.
All right, so Tinkercad is part of a larger family that is Autodesk. So Autodesk, at Autodesk, we empower innovators with design and make technology to achieve the new possible. So if you've ever, driven in a high performance vehicle before or thought about buying an electric car, if you've ever marveled at the architecture of a skyscraper or the ingenuity of infrastructure like bridges or railways, or if you've ever enjoyed the computer graphics in a video game or a blockbuster film, chances are you've engaged with something that one of our customers have made. And tonight we're actually really excited to introduce you to some innovators who are also Autodesk customers who use our technology to make a better world and to achieve the new possible. So we care so much about our customers, but we also care about our future innovators as well. And those are your students. And increasingly, your students have been handed a world full of problems, and they can't afford to accept that the what is. We need our students to think more about what if and what are the possibilities. So how can I innovate to design and make a better world? So when we say the word innovate, we mean, to add value, to improve the status quo, and to make progress now. And when we say design and make, we're particularly thinking about how you can direct your students into really exciting career paths, be it design for manufacturing and assembly, architecture, engineering, and construction, and also media and entertainment. And what we need, to think about how we can encourage our students to make progress now and to, kind of think about how they can address some of these problems that we're facing, we need them to be connectors. We need students to merge fields and to think about even the convergence across different industries. For example, if we think about the construction industry, how can we learn from the design for manufacturing and assembly industry in ways that we can make the building process more efficient, maybe by prefabricating building components or integrating new technologies like robotics. In the construction industry, we can also learn from the media and entertainment industry. So thinking about ways that we can keep our workers more safe by maybe using technologies like virtual reality or reality capture in order to maybe even simulate some of the more dangerous tasks that our construction workers need to think about and do. We also need our students to be collaborators. Our customers are collaborators as well. And even within Tinkercad, your students could collaborate on the same design together in real time. Because we know that in order to unlock solutions to these problems, it requires a diversity of perspectives. And that's actually another big problem right now. It's that a lot of the industries that we support don't have that diversity of perspectives right now currently, and we need to change that. Our students and our future innovators are curious doers, so they see the kind of the relationship between making and learning, and that it's an iterative process. They might also just say, that problems are opportunities, so they have an optimistic outlook that, in crisis, sometimes it's a mix of both danger and opportunity, and what can we do in order to make change now? You'll also hear from our guests tonight that our customers are caring and they care about big issues. And we hope that your students will engage in projects that also kind of address some of these big issues like healthy and equitable communities, environmental sustainability, and accessibility and inclusion. And one way that we try to empower young innovators is through providing free access to about 60 of our professional tools. So you'll actually receive this slideshow in an email after this webinar, and there'll be a link in the notes to where you can find more information about how both teachers and students can access some of these professional tools for free. Tinkercad is free for everyone though. So Tinkercad is a free and easy to use web app that equips the next generation of designers and engineers with the foundational skills for innovation. So 3D design, electronics, and coding. Tinkercad works quite well on Chromebooks. It works on iPads. It works on all types of devices. One of the fun aspects of using Tinkercad on an iPad is you can actually unleash your designs into the real world using augmented reality. So with Tinkercad, you can start small by designing something like a toy car, but then once students are ready to level up, they might want to send that toy car to Fusion 360 in order to add details like chamfers and fillets or cross section, or apply physical materials and render. They might, think big and think about designing a dream house or to be an architect in the future, and maybe design even a dream room. And then once they're ready to kind of move on to something more professional and to think about careers, they might try out Formit, which is our conceptual architectural tool, where they can explore interesting skills like computational design or generative design for the built environment, which Uchenna is actually going to talk about a little bit tonight. They might use the code blocks environment within Tinkercad to learn about how to design computationally or how to create parametric-driven designs. And then they might think, well, maybe I can move on to InfraWorks, which is our civil engineering conceptual software, and place their design into a real location and access data from that location in order to run traffic simulations, for example. But one of my favorite things about Tinkercad, and this I think comes from my growing up and wanting to be an artist, is it really helps students who maybe don't necessarily see themselves in STEM kind of think about how they can use STEM as a vehicle for self-determination, for creativity, and for expression. And they can even level up within Tinkercad. So for example, by accessing the augmented reality feature, they can immerse themselves in their designs, and then they might move on to think about, maybe I want to take my character that I designed and apply motion, joint the parts, rig it, and think about how you might make it move. So these are kind of our 3 offerings from Autodesk that are kind of the basic places to start. So obviously there's Tinkercad, which provides browser-based 3D modeling. Again, it has the 3D design, the circuits, and the code blocks environments. And it's a tool to teach core skills and abilities in engaging ways. You as a teacher, but also perhaps your students, particularly students who are 13 and older, might find inspiration in Instructables, which is a place where you or students could find step-by-step projects. It's also a project sharing platform to build skills and get inspired. There's also tons of contests that we run through Instructables. We're going to talk about a couple of those tonight. And it's also, and I would say even Tinkercad too, in addition to Instructables, is a community for people who like to make things. And lastly, there's Fusion 360, which is our for design and manufacturing. It's a more professional tool. It provides users with an integrated CAD, CAM, CAE, and PCB environment or software. And it's recommended for high school and above. So again, for both Instructables and Fusion 360, students need to be 13 or older to use it. That's not the case for Tinkercad, though. So again, within Tinkercad, there's the 3D editor, there's the circuits editor, and there's the code blocks editor. All editors allow for your students to collaborate together in real time on projects. On the Tinkercad website, there are starter projects, there's examples, there are lesson plans. Your designs or your students' designs autosave. And it also provides you with teacher access to student work. So you can set up a classroom in Tinkercad. You can also create activities within your classroom. So we're really trying to improve the teacher experience in Tinkercad as well. So the 3D editor might be the editor that you're most familiar with. It's a simple interface that encourages rapid prototyping in 3D. It allows you to modify and combine shapes, as you can see here. And you don't necessarily need a 3D printer or a laser cutter to use it. It exports also as images, so students can screenshot their designs. And Jason tonight is actually going to talk about some interesting ways that you can either 3D print or maybe 3D print a little part of the design that the students make. And it also allows you to send to Fusion 360. In the circuits environment, students can design and simulate circuits. They can build, simulate, and code in both Arduino and Microbit. It enables block and traditional style coding. And it allows students to test circuits before building, which is also a very economical feature as well. They can burn out their parts digitally and not in real life. There's the code blocks environment within Tinkercad, which allows you to build 3D models with block code. It enables visual code progression. You can step through the code manually, and you can also control speed code runs. And as you can see here, you can go from something really simple to something really complex really quickly once students kind of master that computational thinking and the basic kind of skills for parametric driven design. And, as students are, mastering Tinkercad and as they grow older within Tinkercad, they're actually able to send their designs directly to Fusion 360. So as you can see here, maybe they're just using Tinkercad as like a place for prototyping and ideation. And then they might send it to Fusion to, add rounded edges or to, add sculptural elements, or maybe they're just sending it there to apply materials and render it to create a photorealistic depiction of their design. And we also are really excited about our ability within Tinkercad for students to actually be able to send their designs from circuits to an electronics environment within Fusion 360. So this enables in one click for students to be able to access a professional PCB design environment that they can further develop their designs through tooling, simulation, routing, and milling. So that's all I've got right now, Jenny.
Yeah, I'll see if I can take it away here. Okay. Thank you for that, Kellyanne. Now we're going to move on, and I'm going to talk a little bit about using Tinkercad as a tool for exploring careers. So a lot of you are probably familiar with an organization called WorldSkills. It's a global organization that has a presence in 85 countries. More than 100 million young people are involved in it, and they represent about 65 different skill areas. WorldSkills is one of those. It's a nonprofit organization. It's one that helps students make connections between their career interests, making industry and business connections, having the opportunity to engage in competition, sometimes at the international level, and just explore their career paths and make connections between their interests and the things that they might do professionally one day. So I want to talk a little bit about career and technical education. In the US, CTE programs are often in middle schools and high schools, and they're designed to help students prepare for the workforce or advanced education opportunities across a wide variety of industries. And what you're looking at here are called the 16 career clusters. These were developed by an organization many years ago called Advanced CTE. And the reason this is relevant for teachers is that these career clusters are often adopted or adapted at the state or district level with some variation in language used. And then states or districts align their CTE standards according to these 16 buckets. I want to show you a couple of examples of how states have either adapted or adopted these. So on the left, we're looking at a county out of Virginia, and this is how they organize their career clusters, using a lot of the same language in the example I just showed you. The one in the middle, I believe, is from Iowa, and as you can see here, they've created kind of some broad categories in which the career clusters fit inside of. And then finally on the right, we've got an example out of the state of Connecticut, and this is how they organize their career clusters. And so your state might organize them differently. You might notice a lot of similarities, but this is often used in middle schools and high schools in the United States. So let's talk about some of the broad goals of CTE. So obviously CTE is all about exploring career paths, making business connections. A lot of students at the middle school and high school levels are interested in earning industry certifications and licenses. They might be exploring opportunities to move on to post-secondary education institutions, 2-year or 4-year schools. Finding work-based learning opportunities is a big focal point for CTE programs, and developing soft skills, things like budget management, time management, interviewing skills, those sorts of things are often part of CTE programs. And then of course, finding job opportunities is a big point of focus as well. And so you might have heard of these organizations called career and technical student organizations. These are actually funded and authorized at a federal level in the United States. Again, you've probably heard of a lot of these, and these are in alignment with the 16 career clusters. So I just want to talk a little bit about how CTE is often structured. And there is a link here, and by the way, there are links embedded all in this PowerPoint that you'll be able to access when we send you the slides next week for further investigation. Now I'd like to talk a little bit about how and why Tinkercad is a great resource for exploring careers or in alignment with CTE programs. So it gives students workspaces in 3D design, in electronics and coding, as Kellyanne was talking about earlier, making it a great tool for building foundational skills for innovation. So these 3D digital literacy and design skills include design and make innovation, spatial reasoning, and computational design, which helps students learn to solve problems in new ways to prepare for tomorrow's jobs in industries like engineering, architecture, construction, manufacturing, and digital media. So practicing these skills also helps students prepare for more advanced software that they might use in a more professional realm like Fusion 360 later on in their education or even in their careers that they're exploring. So one fun thing I like to do is look on social media at what teachers are posting their students are doing. And it's really fun to see snapshots of people's work out there. So I collected a couple that I wanted to share today. These are some teachers and students who are using Tinkercad to explore careers. And the 6th and 7th graders in this one example are exploring the job of an interior designer as part of their career exploration class. There's another example there in the middle where the students received plain gray walls using the new activities feature and were challenged to design an interior space for a particular client. So it's fun to see, students begin to think of their work in terms of like client work, because that is something that they might experience in the professional world later. And then on the right, these students had the opportunity to design and build and explored career opportunities using Tinkercad and learned about the benefits of 3D printing. And just drilling down a little deeper, looking at some potential future architects of Tinkercad, I'll share a couple of examples with you here, and then you can explore this later in your own time in the presentation. But some 4th grade engineer architect students were designing everything from columns, buildings, and abstract art to solar systems using Tinkercad. Friend of Tinkercad and teacher Rob Morrill shared an example of how he was using the transparent view feature in Tinkercad, making a model of a house look like an architect's drawing. It's a pretty cool feature. Over on the top right, we have an example of students who are working on a who, what, and how project involving inventors, designers, and architects, working on reproducing and improving their designs using Tinkercad and other resources. On the bottom, the 6th and 7th grade class was focused on digital technology and worked as designers, engineers, and architects, creating 3D models using Tinkercad. We have an example in the bottom middle there where from an architecture and design class, building off of Elon Musk's Hyperloop SpaceX rockets, pretty cool. And then I like this example on the bottom left where a Shakespeare class was using Tinkercad to learn about making 3D designs in a cross-curricular manner. So they were also connecting it to some math curriculum as well. So that's always fun to see that cross-disciplinary use of Tinkercad. And then taking a look at some potential future engineers at Tinkercad. So one of the classes here was visualizing objects in 3D as an important skill for an engineer. Some students were working through the engineering design process, which we commonly see teachers referring to, creating a product that would be easier for humans to survive on Mars. Another example, students first worked in clay to prototype a project and then design the project in 3D using Tinkercad. And another fun part of this particular project is that it sounds like they connected with an engineer on Skype who uses CAD daily. So beginning to make some of those connections between what they're learning in school and what they might seek to do one day professionally is always fun. Another 5th grade class used Tinkercad to design 3D items to use at home. And another class was working on designing in 3D to create for students who were trying to create a device to prevent other students from using drinking fountains. So obviously a COVID era project, which hopefully we won't have to do too many more of, but it's always really fun to see students' creative use of Tinkercad in many different ways. And then the last example I wanted to show you as far as careers and some potential product designers of the future. These students were designing developmental toys using Tinkercad as they learned about families and children in a home and careers class. And then I really like this example on the right where the students were asked to design IKEA rooms, items, and furniture with a twist. So it looks like they were deconstructing an existing product and then putting their own spin on it and redesigning it using Tinkercad. And those were some really fun projects to see. So given that, I'd like to pose another question to the chat. Tell us about whether your students have used 3D design CAD in exploring careers, and if so, how? And Kellyanne, is there anything in the chat that might be fun to share at this point? I know we've been talking a lot.
Well, someone just said that Tinkercad is just an amazing platform. So we love to hear that. And we always want to make it better.
Yeah, absolutely. Anything else standing out? We can just let the chat continue as we move on.
And someone said that they assign their students to create a water filter. So they're doing that this semester. My students design and then 3D print hall passes. Very exciting.
Oh, fun.
Youth Architecture Conference.
Great. Yeah, I love the real world problem solving.
I had 4th grade students design math models to help visually impaired or students who are blind. Great. So lots of exciting stuff happening in the chat. And please do keep it going.
Yeah, please do. Okay, so moving on, I'd like to go ahead and hand the mic over to Jason, who's going to tell us some about developing CAD schools in middle school. So take it away, Jason.
Great. So thank you, everybody. It's nice to be able to meet with you all tonight. And thank you again to the Tinkercad Autodesk Instructable staff for having me. My name is Mr. Jason Erdreich, and I am the 6 to 8 Technology, Engineering, and Design teacher in Madison, New Jersey. And my courses really range everything from 3D design and CAD to rapid prototyping and manufacturing, as well as some traditional woodworking, materials processing, lots of coding, robotics, a little bit of graphic arts, really just a bit of everything in our sort of modern and design world where my students are thinking about how things are made. And that's kind of what I'm going to be sharing with you tonight. I want to also just point out how I got into this career, and it was talking about my shop classes. So whenever I took a shop class in school, I kind of just felt empowered to like fix things, whether it was fixing my car that I broke because I didn't know how to drive it right, or being able to just create a t-shirt for a cool event or something. And those types of classes just really kind of put me in the mindset of kind of having responsibility for the stuff that I was interested in, and that sort of led me to wanting to share that passion with others. And I'm starting with this slide here with this phone and this computer, and that's because I figured I'd start the conversation with how I start the first day of my class. And that's that we have a pretty awesome technologically advanced world where right now, any of you, if you need anything, could open up your phone and click a couple buttons, and pretty much anything in the world could be delivered to you with like no effort at all. And that's what I like to call the art of being a consumer. And simultaneously, you guys could also open up your phone and go online and learn how to make anything pretty much in the world. I mean, there's an Instructables article on pretty much anything from like washing your car to really awesome cookie recipes. And I bring this up because both being able to purchase and obtain whatever you need and being able to go online and learn whatever you want to learn are like equally accessible. But why then do humans tend towards leaning to be a consumer rather than a creator? And I have this debate with my students on the first day because I want them to be thinking about, you're going to get to this point where you have a crossroads where you need something in your life, whether it's a phone charger or a table or whatever. You could buy it, but you could also make it. And that's something I want my students thinking about right from day one. We also talk a lot about solving problems. So this is the engineering design process I use, and I just want to make it really clear that this is not the only engineering design process in the world. Here's a bunch of other ones that I found online. So sometimes they're called a product life cycle, sometimes they're called the scientific method, or whatever it is, but basically it's a methodical way to go about solving our problems. And it's what real engineers do when there's something, whether it's a new type of prosthetic or a new type of battery or whatever it might be. So we use this design process where I'm putting my students into the mindset of solving a problem that's pulled from the real world, whether it's some type of structure or some type of phone charger or whatever it might be. And they go through brainstorming different solutions and then creating it. And this is a big challenge and also something big that I want my students to understand, so that way when they leave my class, sure, they learn how to use 3D printers and different tools, but really they're in the mindset of, again, being able to solve their own problems, being a creator and not just a consumer. A huge piece of this is communicating our ideas. So I spend a lot of time teaching my students how to sketch and make pictures and explain that if you're inventing something, even if it's something like a chair, you can't just say to your partners and your group members, hey, I thought of a really cool chair, because using our words might not be able to explain that. So being able to sketch it and being able to draw it and being able to share what your thoughts are is a huge skill as we're learning how to design things and solve these problems. That's where computer-aided design come in, also known as CAD, of course. So CAD is a tool where students can communicate. And I don't get rid of sketching. So my students often sketch and design in CAD in tandem, because I actually saw earlier there was a question posed that learning how to create a sketch and do extrusions is a difficult thing. Tinkercad allows students to kind of get their brains in this three-dimensional world, where even if you're drawing on a two-dimensional piece of paper and you're looking at a two-dimensional screen, you're designing in 3D and you're designing these products that you could hold or walk through, interact with. And CAD is a really powerful way for my students to communicate their thoughts and their ideas to their group members, to me as their teacher, and of course to like a 3D printer or a machine. You can't just walk up to a 3D printer and say, make me my chair that I'm thinking of. We need to design it. We need to share that. We need to solve this problem and create it. And these designs can be anything. I mean, these are just some of my students' projects. And I mean, they can think of anything in the world and bring it to life using CAD, whether it's a new type of hairbrush that has like detangler built in. Not that I need that, but you know, I hear it's pretty cool. Or like a new type of phone holder that just clips onto your belt, or a charger that you can actually wind up to charge your phone on the go, a puzzle, a really cool hat with sunglasses, or just a way to sort all these ping pong balls. I, of course, have no idea why we need that many ping pong balls in our life, but you know what? The student thought of it and it was a problem, and then they were able to design it and create it. Or even really cool, affordable, and adaptive prosthetics. So being able to relate to a problem that maybe they're not experiencing, but somebody else is, and being able to connect to that and say, I can design a solution for that. One of my favorites here is actually this really awesome selfie holder that I like to use quite a bit. I had to take this project and just keep it for myself, so it blows my hair in the wind and gives me a beautiful lighting as I take my selfies in my Project of the Day videos here. Now, a question I often get as a teacher is, so CAD's just for like 3D printing and building things? And in short, the answer is no. While Tinkercad works awesome with 3D printing and laser engraving and circuits and all these great things, again, it's really to be able to allow students to express their ideas and create things and solve these problems and communicate that with each other, their peers, the world, in reality, through lots of great collaboration platforms like Instructables or even Tinkercad sharing. So here's a couple projects that were not 3D printed, but using Tinkercad to, again, just share and communicate thoughts, whether it's designing the set of a play and where to position things and do props and stuff like that, designing a really elaborate Transformers-like costume that's going to be made out of cardboard, or creating like an animal habitat. If you're learning about animals and you're trying to recreate the worlds that they live in, whether it's designing a more supportive and adaptive zoo or type of natural preservatory or something, or even like redesigning furniture, right? We can't necessarily 3D print a desk, but we can certainly think about, hey, why are these desks not great? How could we improve them? Or if you're doing a huge project, like a big woodworking project or something, like this massive boat, planning out your cuts and planning out your parts and being able to communicate your ideas is just a really great solving and design strategy that my students use CAD for every day. I also really like to just say that CAD is essentially, it's a tool. It's a tool that we're teaching our students that's going to guide them to their future careers. I mean, in reality, as their teacher, I don't know what future career they might embark in. They might know. I certainly didn't know what I wanted to be, or at least I thought I did, but I'm not an astronaut yet. So, you know, I was wrong when I was in middle school. But you know, without knowing what their careers are, or in reality, their future careers might not even yet exist. Our technology keeps changing every single year, but teaching them CAD, teaching this three-dimensional design skill and this way to communicate their thoughts is, again, a tool that fits into these huge project toolboxes. Even if you're making some type of elaborate circuit box or whatever it might be, learning how to, again, use this design to collaborate and communicate is huge. I also love that in Tinkercad specifically, it's super diverse in what you can do. Recently, it's added a lot more different shape generators and things. So I do a lot of projects where we're not just 3D printing, we're tying in other things, like where students are challenged to recycle or upcycle, where you have to take trash and turn it into not trash. So designing some type of upcycled phone speaker like this, and again, planning it out in CAD to communicate your ideas. Or I've seen a lot of things in the chat about actually doing electronics and coding, and we do a lot of Arduino programming at my school. So being able to plan that out and plan out your circuits and test out your code and share that with your peers prior to building that prototyping stage is a huge real-world experience that my students engage in. I also just love that, again, my students are able to plan and communicate in a much more effective and real-world way. And it's not that we're getting rid of like the initial sketching, it's just that students can really get hands-on materials even without necessarily getting hands-on. Whether they're designing and working from home or in the classroom, planning out things like how am I going to cut and arrange these popsicle sticks to put them together and create a catapult is just a powerful tool. And yes, you can even then throw in 3D printing. So maybe we're going to 3D print a part because I don't necessarily have enough 3D printers to 3D print 100% of my students' projects, and I have lasers and other machines. So students can kind of plan all those different parts where something's going to be cut on a saw and something's going to be 3D printed, and they can put it all together in this three-dimensional CAD world to, again, communicate, share, and solve these real-world problems. So in summary here, I just think that computer-aided design or teaching CAD really unleashes so many things. I mean, it definitely engages my students. It gets them excited. And while I'm a very hands-on teacher, and I don't think anything replaces getting hands-on with those materials, being able to support every student, regardless of what their ability or prior skill or what their needs are, through something that I can differentiate, like Tinkercad, to let them have this success unleash their creativity and just share their ideas to invent really whatever they can think of is just an incredibly powerful tool. And it's, you know, why I love doing what I do. And it's something that I like doing and sharing with my own students and through my own projects. And it's just a really awesome conversation that I'm sure in one way or another is going to guide them to a really cool career. So thank you again for allowing me to speak here. And I can't wait to see what you guys drop into the chat and all the conversations we're going to keep having. So thanks so much.
Yeah, thank you very much, Jason. That was fantastic. I'm sure that you're inspiring many, many teachers on the call today. So I want to go ahead and offer a new question for the chat. I'm sure there's a lot of conversation going on. What Tinkercad project ideas do you have to help students explore careers? So if you have any ideas or examples you want to share, go ahead and put it in the chat.
And I think, Jenny, that many of the teachers have already read your mind with this question. There's a lot of stuff already being shared that's really cool, like students design their ideal landscape that would home a community powered by renewable resources. I do a Save the Planet challenge with my 5th graders. They do paper diagrams, Tinkercad models, and physical models. They are allowed to be creative and not completely realistic. They use Tinkercad to model and 3D print prototypes all semester. So using design thinking outcomes, it's resulted in amazing innovations from solar-powered charging devices and hydro-related mechanical devices, green solutions. So much really great stuff that's inspirational in the chat. And I love how this continues to be a two-way conversation where teachers are connecting with each other too. So thank you for that. And thank you for being such great participants.
Yeah, thank you for that's a lot of really great ideas you just shared. So thanks. Keep the conversation going. In the meantime, we're going to move on, and I'd like to queue up the platform here for Uchenna, who's going to talk to us about CAD skills in building design and construction. So go ahead and take the mic, Uchenna.
Awesome. Thank you so much. This is an honor and a privilege to get a chance to share. Thanks so much to the team over here at Autodesk. My name is Uchenna Okere, and I am the founder and CEO of RevitGods. My background, I have a background in architecture. I went to Temple University. My parents are from Nigeria. I was born in Jersey City, New Jersey. And just to give you a little bit of, of how I got started here, if you guys don't know anything about West Africa parents, there are only 3 careers that we are allowed to be interested in, which is medicine, law, or engineering. I honestly wasn't a fan of either of the 3. I wanted to study art. My parents said no, so I chose architecture. So thankfully, while being in the industry, I fell in love with the technology around the building design industry, and it allowed me to eventually start RevitGods. So RevitGods is a BIM management and consulting firm for the building design and construction industry. We pretty much help building designers and contractors stay tech forward, and we help them design their buildings and do all that in 3D. We have a huge mission to make building design technology really easy to use and accessible to everybody. I honestly believe that anybody, no matter where you are in the world, should be able to design your own building, your own structure, without necessarily having to go to architecture school. You should just, design something, send it to an architect for approval, and then, somehow get it built. So that's what I'd love to do. We're based in Philadelphia, PA, and our core customers and clientele are building designers, building contractors, and building owners. So you're probably wondering, what's BIM, right? So BIM is the industry that I work in. BIM stands for Building Information Modeling. So if you have students right now who are using Tinkercad on a pretty regular basis, and they have any interest at all in being a building designer, a building contractor, BIM is sort of the next step of where they would go in today's industry. When architects or designers create their 2D blueprints or their plans, at the same time, it's also developing a 3D model. So in the BIM world, as you're designing your building, you're also creating a 3D model that's nested with information that contractors can use for schedules, for ordering and coordination, and all types of stuff. So that's just, you know, what BIM is and is what we do. So overall, something that you have to understand is that the building design industry, or architecture in general, it's going through a really huge transformation. And you know, this is important because, you know, if you have students who have an interest in the building design industry at all, in the next 10 years, what the industry is today will be much different by 2030. Right now, the BIM industry around it is taking over. About 80% of projects in the next 10 years will be done using some type of BIM technology. So all buildings will kind of be designed in 3D and coordinated in 3D, and you'll probably manage your building from your phone in 3D. We're actually in talks right now with public school system to scan all their buildings and convert it all digital, which is really cool. So let's just talk about just the BIM industry. And outside of being an architect, being an engineer, or being a building contractor, there's a myriad of other careers that now exist because of sort of the technological advances that the industry has gone through. And what I'm going to do is I'm going to break down each of these careers, each of these career options, and what they actually look like when applied in the building design industry. For the most part, the way buildings are designed today, it's a much different process. So we'll go through it. Now, to tell you the story of and break it down to careers, we one of our first projects, we've been around for about 5 years, and one of our first projects was to coordinate or help to renovate the new Philadelphia Police Headquarters, which formerly this building is in Philadelphia. It's 500,000 square feet, which is basically a city block, and they're converting this entire thing. It used to be the Philadelphia Inquirer building, and they're converting it to the police headquarters. So this used to be the Philadelphia Inquirer building. And so what you're looking at right now is the second floor newsroom. This is a really old building, and it had to go through a pretty extensive renovation. So they called our team up to go through a couple things, because one, they needed to get this thing scanned. They needed to know exactly where all the structure was, so that they could fit those columns that you see there into all of the jail cells on the bottom floor. It's a pretty intense project. So the first thing that we did was we had a team that went out to this site and did what they call a 3D laser scan of that second floor space that we were just looking at where the newsroom was. Now, the people who actually do this, they're called reality capture technicians. These guys, all they do is go to existing buildings or existing sites, and they have a scanner that they place in the middle of a room at multiple points, and they do a laser scan of these buildings. And it's really an amazing career to get a chance to travel and go in and out of some of the most historic buildings in the world. The next step, once we get that laser scan, they give it to what they call a BIM specialist, who will take the laser scan and develop a BIM model out of it. So once they have a BIM model or an existing model of that space, now they can finally try to do a design now that they know what they're working with. Now, design is a little different today, right? Back in the day, you would have an architect who, would, have the existing floor plan, and maybe they'll try to sketch out some ideas. It's a little different today. Today, you have a computational designer who will write a piece of code and plug in the requirements of what they're looking to get out of that building. And that computer will run through a zillion different options within a minute. And your job as the decision maker is to choose what the best option is, and as the designer to start to develop that option. If your students right now are learning, how to use a code blocks in Tinkercad, or learning any form of code, this is where this is this is sort of an application of how this is used in the real world. And these people who do this are computational designers or people who are really doing generative design, which is what this actually is. Now, once they reach a design, then you have a 3D visualization specialist. This is a really fun because this is a person who is taking that finished design and they're rendering it. So they're applying textures, they're maybe modeling additional furniture and assets, and they're going through the process of trying to imagine what this is going to look like once it's all constructed. All right, now once they get to a finished design, they know what it is. Obviously, they have to put the HVAC and plumbing systems into the actual design or into the building. So the HVAC systems within it, if you look up at the ceiling, I think my image here is missing. I don't know what happened, but oh, there it is. Awesome. So if you look up at the ceiling of any building that you're at, if it's exposed, you'll see a bunch of pipes and ducts running above your head. And there's a real challenge in getting all of that to fit. And it's like playing a really elaborate game of Tetris. On the Inquirer building, it took us about 1.5 years to get all of those pipes and ducts to fit above the ceiling. The people who do this are called VDC coordinators or VDC manager. VDC stands for Virtual Design and Construction. These people are professional Tetris players because they're getting this to all fit inside of the building and they're making it work. So this is like the magic that you never see above the ceiling. All right, and now one of our last steps here is construction technologist. Now this role here, especially in the next 10 years, will be absolutely invaluable because of the data that we're getting from the BIM process. We're now able to automate construction, which it's saving lives, it's creating a much better efficiency, and it's helping us be able to put buildings up a lot faster. So instead of going out to site to develop something, you probably will develop pieces of a building inside of a shop and then ship it out to site and assemble it again, like maybe like Jenga, which is a good example of that. And last piece, now once the building is done, you'll have what you call a facilities manager, who their job is literally to, again, manage the building, but they'll have the building on their phone. So if a piece of equipment either needs to be serviced or something goes wrong with it, they can look up that piece of equipment on their phone because of everything that we went through in the BIM process, go out and service it or put an order in or start to track how much energy that their building is using or how much waste or how much water is flowing through the building. Once we have that final process through design and construction, you are able to now manage this building digitally. All right, so this is a sort of a new industry that a whole new set of careers, a new industry that has emerged out of the building design and construction industry. And I think there's really 4 key skills that, if your students at this stage can learn. The first one is 3D modeling and helping your students learn how to think in 3 dimensions. Second is basic coding and visual scripting, learning how computers think. Fourth is just problem solving, learning how to resolve issues and problem solve. And then basic carpentry, which is so important because people have to learn how the real world objects come together. How is the world made? So with that, I am done. It was such a pleasure sharing with you guys.
Thank you so much, Uchenna. I'm just amazed at all the different career options available. I think about sometimes, when students start kindergarten, there's a lot of jobs that don't yet exist by the time they graduate high school. So there's been so much evolution in this field, and it's just exciting to hear about the possibilities. So I want to open up our chat again, which I hope is still ongoing, but I want to pose a new question. What ideas do you have to help students with career interests in the building design industry? And of course, oh, go ahead, Kellyanne. Got some.
One teacher already had an idea for that, which is to
Okay.
share the recording of this webinar, particularly Uchenna's description of all these exciting jobs in the AEC industry with their students. So that's definitely something you can do. And we're going to be emailing the recording of this out to you in the follow-up email. So
Yeah. If there's anything else to share, otherwise we'll move on to Aram's
I think that they're very self-directed in the chat and sharing with each other. So maybe we can move on to Aram, and then we can reflect what's being said in the chat later. Okay,
excellent. And do remember, if you have questions for our panelists, go ahead and put them in the Q&A so we can address those at the end of our presentations. So now I want to welcome Aram to present on CAD skills and product design. So take away the mic, Aram.
Hi guys, I'm Aram Goganian from Predator Cycling. Thanks so much for having me here today. Yeah, Predator Cycling is a design and manufacturing company. We design, excuse me, we design high-end custom road, track, and time trial bikes, as well as components and accessories. We've been around for about 15 years now, and we've done an array of things. So we've worked with a lot of Olympians, World Cup racers, national champions, a lot of competitive sports. So we've had to learn how to optimize all of our geometries. Excuse me one second. So we've had to spend a lot of time optimizing our geometries and our parts. So CAD has been a very important part of our company. We have three main manufacturing protocols that we use. So we do composites work itself. So we're making full carbon parts. We're also making 3D printed parts direct to consumer. And we've just released a hybrid printed and composite workflow for some new parts. A little bit about me. I started CAD work in 6th grade. My aunt was an architect and she had a seat of AutoCAD at home. So I got to go to her house after school and she got to teach me how to draw and use all the different tools in CAD. And the reason I wanted to learn CAD was because I wanted to make my own bicycle. Go figure. So I did. I designed my first bike. And one of the things that CAD was really helpful for me because I'm dyslexic. So I was diagnosed with dyslexia in elementary school and I have a pretty bad case of it. So it was very challenging always for me to get my thoughts onto paper and like explain it to someone. And I mean, till this day, it's frustrating sometimes. And so CAD for me was an outlet. I could very easily get my thoughts onto paper and explain it to people and then actually get my parts made. So it was till this day, it's a good tool for me. So the part that I'm going to talk to you guys about today is a brand new part that we actually just released a couple weeks ago. This was an arrow bar extension. So it's that black part on the bottom right of your screen that you see. This is a racer. His name's Corey Williams. He's a pro rider that's out of Los Angeles. And he has a position that he rides. And in the bike industry, we call this a praying mantis position because it kind of looks like a praying mantis. And he wanted a bar that would optimize, was optimized for his position and would help him reduce the drag so he could go faster. So we kind of decided to take this on. And the way we approached it was using Fusion 360. We used the canvas tool and basically laid this picture and then built the sketch of his bar right in there. And so we were able to basically build the first prototype off of 3 photos and some scan work of his arm. And we were able to make the first 3D printed part that went to him for testing. And this part is actually, it's a very organic shape, but it's actually not super complicated how we were able to make it. We're using a 3D sketch and we're using some T-splines that are referencing it. And then there's about 5 or 6 construction planes with some other sketches to do precision geometry work. And we were able to actually make the whole part. So this is the finished rendered part where you can see some of the more organic shapes. There's kind of 2 focuses on this part. We're trying to, one, contour to his arm so that we're not disturbing any extra air that we don't want. But at the same time, we're actually trying to guide the air around his body so that we can try and keep the the air intact as long as possible. So it's a challenging problem, and you can kind of see here how we tried to attempt to fix it. And this was the render that we sent him for his final approval before we actually made the prototypes. And this is rendered in this is all rendered in Fusion. And then in the next slide, yeah, this one here, you actually see the finished part. So this is the actual bike on his, this is the actual bar on his bike, which he raced I think last weekend. I would have shown you a really cool picture of him racing, but I don't have the rights for the photo. So this is all I have. But yeah, this is the finished composite part. And inside of that part is actually a 3D printed high temperature skeleton. And then the exoskeleton is actually fused on with fused carbon fiber. So it actually becomes a singular part. And the arm pads up there are also a separate part that are bolted on so that you can adjust it for some fine tuning. And then those are actually a thermoset molded part that we also did in Fusion, which is, it's a cool little tricky part. And again, all of this is built on CAD. So all of these models, the designs, everything goes to 3D printing is all CAD work. And then here, this is one of the parts that kind of we were able to make a name for ourselves on. This is what we called the major handlebar, and this is the pilot, the version. So this bar went to, for the US, went to the Rio Games to race, and it is a bar stem system for primarily track racing for the velodrome. And this bar, it contours to your hands really well, and it's able to allow you to hold different positions so that you can get, you can ride in relief, so you get a little bit more rest, and you can get a little more aero position. Because it's also one piece of carbon fiber, it's incredibly stiff and incredibly light. This part was actually made prior to Fusion's ability to do 3D sketching, and was done with 3 separate sketches, and then again, it was referenced with some construction planes and then built entirely in T-splines. Even, you don't see it in this picture, but in the back of it, all of the bolt holes were done in T-splines, which was a little tricky. This is our RF20. This is our road frame. And this bike, if you are a CAD lover like me, this bike is a lot of work. I think this took us about 6 or 7 months to finish the entire model. So every single part of that bicycle is modeled. So every single pin on the chain, there is, I believe it's 298 pins. All of them are modeled in, and it's done as a full assembly in Fusion. And all of the outer links, inner links, ball bearings, races, seals, everything has been modeled in. So this is essentially the buzzword digital twins. This is a digital twin of an actual functional bicycle. And it's super powerful to do this because this allows you to have an exact duplicate of the actual bike, but digitally. And that allows us to run simulations. So here you see us running a CFD simulation of the actual bicycle itself. And we're able to analyze the different rotors that we can run on here, different brake mounting locations, what size rotors we run, and if it has any sort of effect on drag. We can actually test the efficiency of the chain and chain link and power lossage in different cogs. All of these things we can kind of start figuring out, and then we can actually run, we can run equations and actually figure this out parametrically, so we can actually update different layup schedules, different tube designs and cross sections, and come up with different ways of testing it, so we can run thousands of simulations overnight to figure out what the most optimal shape is, what the optimal layup schedule is, tire pressures. I mean, countless things we can test for in simulation. And this is another part. This is actually the first part we actually made in Fusion. That was a production part for us. This is a number holder that goes on the back of your bicycle. So if you ever watch the Tour de France, you kind of see on the back of the bike, you see this little number. This is a little carbon fiber bracket that holds that number. And we used to make the part prior, and we used to just do it by hand. We made a handmade mold. We would lay carbon fiber, we would roll the carbon over the mold, and we would vacuum it and heat it. And we could make about 10 parts a day. It was a couple hours. It wasn't too bad, but it was kind of annoying. No one wanted to do it. So when we came up with this part, we actually designed the mold in CAD, and then CNC cut the whole thing out, and then made 5 of those. So we could end up making about blanks for about 50 number holders. And then we could set up this jig here where we could cut 10 pieces out. You see on the back side where there's like a boring type operation that cuts the holes in the back. That's the first step. And then you flip it over to the other side, and then you mount the screws in, and then that will go ahead and cut the contours out. And that was our first part that we did. And it took us from an hour, 2 hours, every other day to about, I think it was about 8 or 9 minutes for a full cycle here. So we would take it down to about 45 minutes on a Friday. So it was a big improvement. So yeah, that was, the CAD is the fundamentals of all of this. So all of our models, everything we build is built on CAD. That pulls and translates all of our simulations, all of our data, even our rider feedback. So CAD is a very pivotal part of our business.
Yeah. I was just fascinated by all the detail and all the thinking and creativity that goes into creating all those parts. So thank you for sharing your story and your examples. I want to encourage you all to answer another question in the chat. How might you help students who want to build advanced professional CAD skills? You heard Aram talk a lot about using Fusion 360. That's an example of a more professional tool that students might be interested in. What ideas do you have to help them, students who want to build those CAD skills in a more advanced way? How's the chat looking, Kellyanne?
Well, we do have one elementary educator who's been inspired by the presentations tonight, and she's wondering, is there a list somewhere of engineering, real world problems that her engineering students can think about? So it's really cool to think that teachers, even in elementary school, are starting to explore these questions.
Yeah.
Someone noted just, thanking Aram for sharing his story, that they really love the fact that Tinkercad helps people with dyslexia. So, thinking about Tinkercad not just as like an engineering tool, but as like a communication tool for students who might need, another way of expressing their ideas. Someone said design challenges are a great way to improve students' Tinkercad skills.
Mm-hmm.
I also asked the special education teachers what are some frustrations their students experience. So kind of building upon that awesome conversation that Aram had started. Mm-hmm. We have a Maya user. So cool. Using Maya is one of the tools that they teach students once they graduate from Tinkercad and Fusion 360. Mm-hmm. So lots of awesome stuff happening in the chat. Oh, reverse engineering challenges, which was cool. Was it Jason showed, or no, was you had showed earlier, Jenny, the example from the IKEA reverse engineering.
Right, yeah. Reverse engineering.
Those are always great.
Yeah, fun. Well, let's, go ahead, sorry.
There's lots of good stuff, so I'm enjoying reading it.
Yeah, I'm jealous I can't really take a look at the chat while I'm doing this. I'll definitely check it out a little bit later. But anyway, I can go, oh, there we go. Does everyone see the poll?
I did it.
Okay, fantastic. So we've got another poll question here. So we'll just give you a few minutes to take a look here.
So far 100% or close to, now it's going down a little bit, but lots of people are saying they're gonna use something that they learned today in this webinar.
Great.
So really great responses.
Let's give that another second or so.
And if this webinar wasn't helpful, please let us know in the chat as well. What can we do to make it better? We do have one more webinar that we're going to be presenting this school year, and I'm sure we'll probably be back again next year. So we're always trying to improve the experience for teachers. We couldn't do it without you.
Yeah, absolutely. Yeah, we'd love to hear your feedback. Tinkercadlearning@autodesk.com is another great way to get in touch with us if you have ideas or feedback.
But we have lots of great feedback that teachers found a lot useful from tonight's presentation. And I definitely learned a lot too. I'm going to end the poll for now, Jenny.
Okay, sounds good. Okay. So yeah, again, do use the Q&A box. We're getting ready to do some questions and answers with the panelists and the Tinkercad staff. But before we do that, I just want to talk a little bit about some resources we have for your students who might be asking, what's next beyond Tinkercad? They might be showing signs of wanting to do advanced CAD or doing some fancier designs that that move beyond what Tinkercad can do. So we've got some resources for you. We have a collection of videos called How to Level Up from Tinkercad to Fusion 360 that kind of walks you through some tips and tricks for moving from Tinkercad to Fusion 360 when your students are ready. We also have a collection of videos on how to design a helmet practice project. And this comes with a PDF with a step-by-step guide. And you can find these resources by accessing our blog link here. And again, you will get this slideshow so you can explore these links however you wish on your own time later. But that is there for you to explore as a resource. And then Kellyanne, would you like to talk a little bit about the next webinar?
Yes, we've so enjoyed your participation. It's been so awesome to watch the chat this evening. We are going to be hosting one more Teaching with Tinkercad webinar this school year. It's going to be on March 24th. And it's going to be on the topic of cultivating an entrepreneurial mindset with Tinkercad, particularly thinking about even as an extension to this conversation around CTE education, because we know that entrepreneurship is kind of one of the strands that a lot of CTE teachers must focus upon. But we're going to have a special guest, three-time Super Bowl champion James Devlin, who retired from the New England Patriots in 2020, has a background in mechanical engineering, and his new venture, reimagining his new possible, is as an entrepreneur. So he's going to talk a little bit about his entrepreneurial journey, and we'll be also joined by awesome guests, Vicki Wu Davis, who is a video game entrepreneur, who's also an educator. She has a youth entrepreneurship program in the Boston area called Y Cities. And we're also going to be joined by her awesome students who are going to talk about particularly how they used the Tinkercad to Fusion pathway in order to express their entrepreneurial thinking. And also some more great opportunities for your students. So there are two contests that we're highlighting from Instructables for this webinar. So one is the Make It Modular Student Design Challenge. This is a design challenge that's actually inspired by James Devlin's journey as an entrepreneur. And it's going to be offering $50,000 in total prizes that are meant to be scholarship awards for students. So this will be open to high school students because it's going to be run on the Instructables platform. And we'll be able to share more information. It's going to launch on March 7th. And it will run until the end of the school year. Another exciting challenge, so for the design for manufacturing and assembly industry, so particularly if you were inspired by Aram's presentation, there's more that your students can learn in thinking about not just bicycles, but also lift trucks. So this is another contest that we'll be launching. This is on March 14th, and it is presented by Fusion 360.
Yeah, we have a number of ways you can stay connected with us. You know, but part of our objective here is to build community among educators with our staff here, and so we can learn from each other. We have all sorts of links here that you can access when we send you the Google Slides. We have a blog, we have presence on Instagram, Facebook, Pinterest, Twitter, etc. And of course, there's our email address if you'd like to get in touch with us. And everyone will be receiving a certificate to recognize the hour plus at this point, I think, that you've spent in professional development with us tonight on the webinar. So you will receive that in your inbox along with the other goodies we're sending out next week. And one last chat question, you know, how can we best support you in your Teaching with Tinkercad journey? Again, we always want to hear your ideas. We're here to make sure that we're giving you resources that help you with your students in the classroom. So feel free to contribute ideas in the chat, and we'll make note of those ideas you're sharing. And with that, I want to go ahead and move on to our Q&A with the panelists. And to do this, I think I'm going to stop sharing here so we can reveal ourselves here. Yeah, let me put the gallery view on. There we go. Okay, so what questions do you have from the Q&A? Looks like there's been a lot that have been answered already. Well, I'll start with a couple questions. So I want to start with you, Jason. Can you tell us a little bit about how 3D design and CAD skills have helped shape your career in your professional role?
Yeah, so I think I mentioned originally that I became the shop modern tech teacher I am because I love those shop classes. And for me, it was very traditional. I didn't really get along with computers that much when I was a student, or a kid, I should say. I always preferred working with my hands and building. But once I kind of entered CAD, which actually I started from like the graphic design perspective and making logos and things, I realized that, again, just to kind of get my ideas out and communicate my thoughts, it was huge. And I mean, now I use CAD not only in my classes to teach my students, but I mean, there's things all throughout my house that I fix things, whether it's just like a little adapter to fix my faucet when it's leaking rather than going down to the store, or, you know, a way to, you know, hang my keys or whatever it is. So being able to kind of solve my own problems and create the things I need has quite literally, I mean, just changed my life from day to day. And that's something that I show my students. I mean, even this webcam that I'm using right now is on my own custom little bracket just to hold it and give me, you know, proper lighting so you guys can see me so nicely in this webinar.
Well, thank you. Uchenna, I'd like to ask you the same question. How have 3D design and CAD skills helped shape your professional role or your career?
It helped me get a job. You know, I think the biggest thing to understand is that most employers, when they're hiring kids right out of college, they're not expecting them to be, you know, some top designer out the gate. A lot of times they're just looking for raw skills. And having the CAD 3D skills allows you to get a job, gets you access to opportunities, and gets you access to mentorship. And so I would say like those things are just the baseline. I had a lot of that because, you know, I'm a natural nerd and I love this stuff. So I was able to get a job pretty quickly right out of college. And that's what I used eventually to start RevitGods.
And how about you, Aram? How did 3D design and CAD skills help you shape your role in your career?
Well, I mean, it gave me my career. Really, I started it because I could model it. I mean, if I wasn't able to model it, we would have never built the first bike. So, and then it kind of just grew from there. Yeah, I mean, it's literally the foundation of, I mean, Predator. It's modeling that led to simulation, that led to, more data that we could pull in to make better bikes. So.
Jenny, did you see the algebra question? It's a good
No,
question.
I didn't.
So what role does knowing algebra play in the guests' respective industries?
Yeah, who would like to take that on?
Uchenna seems entertained by the question.
You know, that's a funny question because we use very little math. The only time, in most firms and even in my company, there's usually only one or two people who actually use any form of algebra at all. And we toss all the questions to them. I think the biggest skill is just knowing how to count and just basic math like multiplication and addition, because we always have to measure, we always have to count stuff and do that stuff. I think, counting and just understanding how to look at data is probably more important than algebra.
Anyone else have a perspective on the role algebra plays you'd like to share?
I mean, I'll agree with Uchenna that, the calculation, I mean, we do a lot of volume calculation. Like we make things that are measuring cups and things. I think that's actually one of the Tinkercad lessons too. Like where, I'll tell my students that they have 12 cubic inches of volume and that's a constraint for their design challenge. I do a lot more algebra when I'm teaching coding, where we're making variables and we have different things where if you're coding some type of speed for an LED or a servo motor rotation and that kind of thing, I do definitely a lot more of that algebraic stuff and more like the calculus and geometry and the CAD side of things for sure.
Yeah, for sure we do it because like all of our models are parametrically driven. So we don't want to rebuild our entire model from scratch every single time. So we use equations inside of our parameters so that we can actually build everything out. And then we also do it in simulation. When you get into simulation, there's a lot. I mean, you're not doing a lot of the math. You're setting up the math so that the solvers will run the math. But yes, there's lots of math, and you have to at least know how to set it up and understand what it's trying to do so that you can set it all up correctly. So your mental math skills though get weaker, I think. But yeah.
We have a couple other questions that have come in. So this participant asked, can you ask the education backgrounds training for the professionals in the field? Who would like to start that one? Jason, would you like to start?
I saw that one, and I'm going to give kind of a broad answer because it depends on the age group and the state. In reality, 3D design, as we talked tonight, I mean, it's just an awesome skill that is communication and expressing your ideas and preparing for these careers, right? So that could be tied in any subject area. I know that social studies teachers in my school learn about cylinder seals, like an ancient way of stamping that's from Mesopotamian times. And they're designing cylinder seals in Tinkercad in social studies. I also know that elementary school teachers are creating characters and scenes from storybooks that they're reading, right? So it's not like you need to have a specialized degree to use Tinkercad. I mean, it's for everybody. If you're asking more of like what educational field does 3D design and manufacturing fit in, typically that falls more into the industrial arts or technology education or engineering education or STEM or STEAM or whatever your state is currently calling it. And that obviously kind of potentially, like my degree is in K-12 engineering education, which certifies me to teach those higher level shop classes. But I know that in New Jersey, at least even at the younger age group, any science lab art teacher could have 3D printers and machines in their classes and get their students involved and engage with that. And again, I've seen a lot of great ways to really tie it into every subject area. So if you're a teacher and if you're interested and if your kids are going to be interested, which I can promise you they will be, you could probably start doing it right now in whatever field you're currently in.
Great, thank you. Uchenna, did you want to share some about education background training for what you're in?
Yeah, and so I didn't start learning anything until I got to college. Before college, I took art and acting classes, and obviously both careers didn't really fly with my parents. So I started learning. I took my art skills, translated into architecture, which really translated into a lot of hand model making, 3D modeling. Funny enough, a lot of parametric design where I did use a lot of math in college. I just didn't really use any math when I stepped into the profession.
I wanted to add too to Uchenna talked about BIM specialists, and that's like a job where I actually met a student who just studied how to do BIM modeling in high school at a CTE school, and she was actually hired right out of high school at a mechanical engineering company. So there's some of these skills too. It's like it doesn't necessarily require a 4-year degree. It's just that kind of that basic CAD training.
Mm-hmm.
That's a fact. If there's a 18-year-old who just graduated from high school and knew how to use Revit and had like the BIM skills, they would get a job almost immediately working for any fabricator or contractor, because there's a lot of hours and a huge demand for people who just know how to model and create the stuff.
There's an interesting conversation happening in the chat around girls. Did you see that?
I did. I was just scrolling through it. I wish I could read it all in detail.
So someone had asked, are there any ideas from the panelists in terms of how to engage girls in some of the types of skills that they might need to enter these careers?
That's an interesting question.
I mentioned earlier, somebody also asked just like engaging students in general and how do you get them motivated and what types of projects do I often assign? And I mentioned that there's the goals for sustainability, which I know Matt dropped the link for, that are just awesome themes from like world hunger and, infrastructure redesign. And like, those are just great topics that I talk about all the time. But I try to always incorporate passion projects where students, once we kind of cover the basics of safety and the skills and they've gone through these things and they have an idea of the engineering design process, that they are, again, in control. And, whatever they're interested in, whether they, play a sport and they want to design something for their sport team or to organize their bag to keep their things in, or even if they play an instrument and they want to design, some type of thing for their instrument or whatever, when students kind of say, this is what I'm interested in. I think we all know that as teachers, that when like you have that investment and you can see that you can create that. So whether boys, girls, whatever it might be, giving that open freedom and saying like, listen, you're in control now. What do you want to create is definitely a great way to get them motivated. And I find that often works better for me than like a specific theme that I think I know what the kids are going to want to do, and then I'm almost always wrong, and then I just kind of let them take over.
Yeah, and I agree with that too. Like I don't think I've ever seen a difference where, girls are interested in this and boys are interested in this. I'm actually really surprised, by, what everyone is sort of interested in. I think the biggest thing to really focus on is really the overall topic and theme. And if it speaks to, just generally what they're interested in. I think, regardless of what the engineering or Tinkercad activity is, if there's a compelling enough theme or just subject that the students are designing around, I think it'll spark anyone's interest, regardless of, gender.
Yeah, any other questions? Did anyone make any note further up in the chat when I was talking of any other questions that might have come up? I know we're a little over our time too, so yeah, if there are any other questions for our staff, it looks like we've answered a bunch of those in the Q&A. Very good. All right, well, I guess we can wrap up our webinar this evening. Please be looking for the resources in your inbox. We'll be sending it early to mid next week. You'll get a link to the recording as well as the slides and the certificate. And I want to give a very special thank you and just a note of gratitude to our panelists. We're super excited that you agreed to join us here tonight to share your stories, share your experiences, some projects that you've done. And I know that the participants on the call will find a lot of inspiration in what you shared this evening. So thank you everyone for taking the time. And it was really fun to be here with you tonight. Thank you very much. Bye.
Thank you, guys.
Thank you.
Thank you, guys.